Welcome to The Explainer, everyone. I'm so glad you're joining us today because we are looking at a topic that is equal parts fascinating and, well, deeply alarming. We're going to examine a microscopic entity that completely defies expectations based on how it looks. It's an absolute master of disguise. We're talking about a tiny organism that causes massive global disruption, and it has been making headlines recently for all the wrong reasons. We're looking at Shigella. Get ready because the way this tiny threat operates is absolutely going to blow your mind. Okay, just listen to this description for a second. The rod-shaped bacteria resemble fat, furry cartoon caterpillars. When you hear that, what comes to mind? Something cute, right? Something harmless you might see in a Pixar movie. Well, when scientists first put Shigella under the microscope, this is exactly the captivating sight that greets them. Stained and magnified, it doesn't look like a vicious killer at all. It just looks like this bizarre, fuzzy little bug. But as we know all too well in the world of biology, appearances can be incredibly deceiving. Okay, let's dive into this contrast because, wow, is it jarring. We have this captivating, almost adorable visual anomaly on one hand, but the dangerous reality? Shigella is a gram-negative, highly contagious bacterium. It causes a disease called shigellosis, which we'll define in just a moment. But I really want you to hold this dichotomy in your mind as we move forward today. This fuzzy little caterpillar is actually a remarkably dangerous pathogen that infects millions of people around the globe every single year. To really grasp how serious this is, we are grounding today's explainer directly in recent medical reporting. Here's a recent report detailing the virulent bacterium, breaking down the latest research on how this pathogen operates and spreads. See, this isn't just theoretical textbook science. This is an active, ongoing medical crisis that public health officials are fighting in the real world right now. So let's unpack exactly what this report is telling us about the Shigella threat. Section 1. The reality of shigellosis, a microscopic threat. Time to look past the fuzzy exterior and understand the biology here. Let's start with a clear definition. When that bacterium enters your system, it causes shigellosis. Basically, this is a severe diarrheal disease. The symptoms are incredibly harsh: high fever, intense abdominal cramps, and bloody diarrhea, which you probably know as dysentery. To give you some historical context, this isn't exactly a new enemy. It was actually isolated way back in 1897 by a bacteriologist named Kiyoshi Shiga. He discovered it right after Japan suffered a devastating dysentery epidemic, and the entire genus of the bacteria eventually took his name. So we've been battling this for well over a century. 10 to 100. That is the exact number of bacteria you need to ingest to become infected. Think about that for a second. Most bacterial infections require thousands, sometimes millions of cells to actually overwhelm your immune system. Not Shigella. Just 10 to 100 of those microscopic caterpillars sneaking into your body through the fecal-oral route, which essentially means through contaminated food, water, or unwashed hands, is enough to bypass your defenses. It can cause an infection and potentially trigger an entire community outbreak. It's just wildly efficient. And that microscopic efficiency perfectly illustrates why it's so hard to avoid. I mean, where does it hide? According to research in our source by Neelam Taneja and Abhishek Miwara, the primary reservoirs are humans and primates. But just look at the rest of this list. It's in rivers, coastal waters, surface waters. You can get it from eating fish harvested from sewage-contaminated water. It hides in free-living amoeba, insects, birds. You can even contract it from crops grown in contaminated soil or water. Literally, if you accidentally swallow a tiny drop of contaminated water while swimming, that dose of 10 to 100 bacteria is all it takes. So we have this incredibly low infection threshold combined with an organism that hides virtually everywhere in our environment. The result? A staggering global toll. 600,000. That's the estimated number of global deaths caused by Shigella every single year. Let that sink in. This fuzzy microscopic organism causes between 80 to 165 million infections annually. And the heartbreaking reality is that the death toll overwhelmingly impacts the most vulnerable among us, children under 5. Particularly in sub-Saharan Africa and South Asia. Section 2. The Kerala Outbreak Crisis. Let's bring those massive global statistics down to an immediate, localized community level. The state of Kerala has unfortunately had repeated, devastating brushes with shigellosis. If we look at the timeline from the health department reports, a very clear pattern emerges. In 2009, over 300 people contracted a foodborne infection across the state. Then, in December 2020, an outbreak in Kozhikode tragically claims the life of an 11-year-old and infected 40 others.
By May 2022, a mass food poisoning incident in Kasaragod resulted in 30 hospitalizations and the heartbreaking death of a 16-year-old girl. And then in late March of 2026, the whole cycle repeated in Kutikatur, Kozhikode, where a 3-year-old girl died and over 60 residents, mostly children, felt deeply ill.
Let's look a little closer at the specifics of that 2026 crisis, because it escalated rapidly. First detected in late March, by June 12th, the health department was tracking 132 confirmed cases and about 75 probable ones. 3 deaths were linked to the disease that year alone, and again, 2 of those were children under 5. But the absolute most alarming cluster emerged at a school in Wayanad. Over 300 children were hospitalized. Just imagine the panic in that community. Experts eventually traced the infections back to contaminated water and food sources, made worse by poor hygiene practices. It perfectly underscores how vulnerable crowded spaces, like schools, are to a bacterium that only needs 10 tiny cells to start a chain reaction. Section 3. The antibiotic dilemma. This is where the treatment side of things gets really complicated. Now, for mild Shigella infections, the human body can usually clear it on its own, provided the patient stays really well hydrated. But severe cases? Completely different story. They absolutely require targeted antibiotics to shorten the grueling duration of the illness and prevent life-threatening complications. But here is the massive problem the medical community is facing right now. According to the U.S. Centers for Disease Control and Prevention, some antibiotics are simply no longer effective against certain types of Shigella. The medicine is quite literally bouncing right off of them. Now, what's really terrifying about this is perfectly summed up by researchers Taneja and Muwara. Looking at the situation in India, they warn, quote, there is a nationwide presence of multi-drug-resistant Shigella developing rapid resistance to most antibiotics available. The bacterium isn't just resisting one drug anymore, it's rapidly evolving to resist almost everything we have in our medical arsenal. It's an evolutionary arms race, actually scratch that, it's a sprint, and right now, the tiny fuzzy caterpillar is moving incredibly fast.
So the crucial question becomes, what is our defense? Well, we can't just blindly throw pills at the problem anymore. Healthcare providers must order specific laboratory tests. The vital defense involves continuous surveillance and the use of local antibiograms, which essentially means doctors have to constantly test to see which specific antimicrobials still work in their specific local area at that moment. Furthermore, the report heavily stresses the judicious use of antibiotics. We have to stop overusing these medicines so the bacteria don't get as many chances to learn how to defeat them. Which brings us to this final thought. We started today by looking at a microscopic anomaly that resembled a cute furry cartoon character. But we end with a global killer that thrives everywhere, devastates communities like we saw in Kerala, and is actively learning how to survive our very best medicines. If this tiny, highly contagious caterpillar is rapidly outsmarting our medical arsenal, it really makes you wonder, are we truly prepared for a post-antibiotic era? It is a daunting question, but understanding the threat through the evidence we've explored today is the first real step in getting ready. Thank you so much for joining me on this explainer. Keep asking questions, keep looking at the evidence, and I'll see you next time.